Let's last one. Last fellow. Yourself, stand up. So what is the function of interface here? Don't laugh. Who is laughing for them? I laugh. What is the function? So somebody told the answer is always IO devices are not directly connected to the bus. It requires interface. So now what is the function of this interface? I am not asking something else. I have already explained this part. What and all it contains interface circuit. So before interrupt there was one topic IO access. So now what is the function of this interface we need to discuss. Can somebody tell what is the function of IO interface? For each device, any device you take, there should be an interface. If you know the answer, stand up. Class. Yes. Control.
Control the signals on the devices which need to access.
How it is going to control? Like what are the important days? If you know the answer, stand up and tell. What are the important components that is present in the interface? Yes. Second, you are not. You are written or not? I don't think so. It will be the report. Listen. Answer now. What are the components? I told you to stop your discussion. You are not ready to answer and you are not ready to listen. Yes? Decoder. What is the function of decoder? Decode the address. Whatever the address that comes on the bus, it is going to decode that address and it will try to match with the device address. If it is matching, then that particular device will respond to the request. Next. Control. What is the meaning of that? Control signals. Okay. So that is the device is ready or not. So if you go back to the one more topic called basic IO operation, we have discussed two flags. What are those with respect to IO? Do you remember? S in and S out. Okay. So those flag information it will be available in the control circuit. If the device is ready to perform the task, it is going to set the flag to 1. Otherwise, it will be 0 if it is not ready. So that information it will be there in the control circuit. Then we have data and status register. What is data? What is that? How it will store the data in the interface? Where it will store the data? What we call those? Registers. What is the name of the register? For input device, for output device. Data in, it is the, either you can use the term register or you can tell that it is a buffer. Okay, with respect to input device, and this is the buffer with respect to output device. Okay. Okay, just note down. What are the functions of interface? Hey, who is that man? Last 3 bench, I will send you out. Note down. What are the functions of IO interface? Okay, it can be asked for 2 marks. Explain or write the functions of IO interface. Provides, first one, provides storage buffer for at least one word. Storage buffer for at least one word of data. For at least one word of data. Okay, it will support for buffer storage. Next, second one, contains status flag, contains the status flag, FALAG. So where it is going to store 1 bit information. So contains the status flag that can be accessed by processor, to determine whether buffer is having valid data or not. Whether buffer is having valid data or not. Okay, status flag contains in the status register where the processor will be able to check the device is having the valid data in its buffer or not. Next, third one, contains the address decoding circuit to determine when it is being addressed by the processor. I'll just repeat. Contains the address decoding circuit to determine when it is being addressed by the processor. Next, fourth one. Yes, fourth one, it generates the appropriate timing signals. Required by the bus. And also one more important. Shall I repeat? Generates the appropriate timing signals required by the bus. Next, fifth one. Performs format conversion. So this one I have not explained, I will just add it. Performs any format conversion that may be necessary to transfer data between the bus and I/O device. It performs any data conversion that may be necessary to transfer data between between the bus and I/O device. Okay, so what is the meaning of here conversion? So conversion here indicates that the data can be transferred in two modes. Yes, finished. The data can be transferred in two methods. One we call it as so the data can be transmitted in two ways. One is called parallel mode and the second one we call it as serial mode. So what is the meaning of parallel mode? So where it can send group of bits parallelly, between the bus and I/O device. Sometimes the bus if it is supporting parallel method and if device is supporting serial method, example your keyboard, it supports for serial transmission. Then how exactly it is going to accept the serial format to parallel? So for that it requires the converter. In the input device interface where it will be having the converter where it will convert from serial to parallel mode. Or if it is voice over also acceptable. So that is from parallel to serial mode it is going to convert the data. What do you mean by parallel and serial? So parallel means at a time it is going to send the set of data from D0 to D7. This is parallel. So serial means it is going to send only one bit at a time, D0, D1 and so on. That is called as serial transmission. So whenever if bus is supporting something particular format and device is supporting some format, it requires the converter. So where this converter will be available? It will be there in the interface. One is address decoder, then buffer, that is for storage, then control signals, then status flag. So all this information it will be there in the interface. Okay. So now, whenever if the device, whatever the device you take, so it has to be connected to the bus. So how it is going to connect? So for that it requires different types of ports. So that port we call it as parallel port and serial port. Okay. So if I have this device. Okay. So now if I want to connect to my device, it requires the port. Can you see there is a port so that I can connect this device? Even this is actually wireless mouse. For this also I need an interface. So that is also connected through the port. So that port can be classified into, once again, parallel port or it is going to be serial. So parallel means, so it is going to transmit the data parallelly. Serial means only one bit at a time. Okay, you should know this. What are ports? Okay. So we'll go with the parallel port. Just take this diagram quickly. Parallel port and serial port we are going to discuss. So just this is the diagram in the website. Can you see there are some of the terms we have already used? Okay, so I'll just explain the process how the parallel port works. This is where we are taking an example of, is it input or output? Check the diagram. Which device we are considering? Okay, what's the name? Input. Why? I've given directly their keyboard switch. Okay, now I'm going to explain what happens when you press a key, how that information will be sent to the processor. See, you just observe so many operations it is taking place when you just press one key from the keyboard. Finished? Hey, I just told you to write, not to discuss. Yourself, get up. Take your book, go outside. Stand up, stand up. Take your book, go outside. What happened? You don't want to go? Huh? Then why you are, what you are doing? Where you are writing? See, this is last warning. Once again, if you repeat, I'll send you out. Finish. Okay, you just keep continue. I'll explain. Test, listen here. Stop writing, listen. Stop writing. So now from this diagram, you can clearly understand that it is input operation. Okay, so where processor is going to read data from the keyboard. So now how that process works, listen carefully, because you have complex circuit diagram that I am going to leave for you. So this block diagram I am going to explain. So if you understand this block diagram, so the circuit diagram you can easily understand. Okay, last bench, stop writing, listen here. So your keyboard is connected to the bus. Okay. So what happens now? You need to understand that I have pressed a particular key. What happens? It is going to read that key, whatever I have pressed. Okay. And it is going to perform encoding. What do you mean by encoding? It has to convert whatever the character I have pressed to ASCII value. Okay. And that data it is going to store into its buffer, input buffer. So the keyboard, the associated buffer, we call it as data in. Okay. And at the same time, so it is going to send a signal called control circuit, a valid control signal, okay, indicating that as soon as this control signal is sent to the interface, it indicates that there is a valid data stored in the input buffer called data in, and once valid signal is received, it is going to set the SIN flag to 1, indicating there is a valid data in the input buffer. Okay, after that, what happens? So that data will be sent to the processor. Okay, so now in between, if it is just read operation, I have just started from getting the data from keyboard and stored or sent to the processor. Now, how processor is going to address which device has to send the data? Last two members stand up. Last two members stand up. So now, whenever if the data should be requested from the keyboard, so what and all information the processor should send? Yes. So now processor want to read the data from keyboard. So what and all information it has to send? It has to send the address, okay, to which device it is going to make the request, and also it has to send the control signal called read or write, okay, and also at the same time it is going to activate or it is going to inform to the particular device that is master ready, okay, indicating the address and request, that is read or write operation, it is placed on the bus. Okay, once it is received, so immediately the keyboard it is going to identify itself and it will read the data. Okay, whatever the data it is sent, it will be placed onto the buffer, and from buffer the processor is going to read the data. Once the data is read, so immediately this flag should be set to 0. Okay, SIN flags should be set to 0, indicate that there is no valid data. Okay, whenever if you press one more key from the keyboard, it is going to change S into what? 0 or 1? 1, indicating there is a valid data that is stored in the input buffer. Okay, and immediately the processor is going to read the data from buffer and it will process the data. Okay, so that is how parallel port works. So now this is the circuit diagram. So whatever I told, this is block diagram. So now if you go in level depth, okay, what and all the gates are used. So how exactly the signals are sent. So for that you need to write that parallel port input interface diagram. So you need to draw this diagram. So here you need to understand very simple diagram. Okay, so where you can see this we call it as 3-state drivers. Okay, 3-state drivers. Okay, where it is going to get the data from the keyboard and that will be sent to the bus output lines. So how many output lines I have specified here? D0 to D7. And also you can see there is a status flag. Whenever key is pressed, it has to activate the valid signal. Correspondingly, it is going to set the SIN flag to 1. Okay, SIN flag is set to 1. So you can just observe the same information, that is address. It is sent from A1 to A31. That is total number of address bits are 30. Is it 30 or 31 bits? Okay, total 32 bit. In that, 1 bit it is used for specifying the what type of operation. Okay, A0 it is going to carry the what type of operation, is it read or write, to indicate that it is going to use the line A0. Understood diagram? Go through. I have written there. Just read out how this circuit diagram works. Any doubt in this diagram? If no, I'll go to the next one. Next, I'll go to the output device. Okay. What is output device here? Printer. So I have considered the output device is printer. So what is the function of that? It is going to print or display that information whatever it is sent by the processor. So that means it is what type of operation? What type of operation it is? Operation. Output means what? Write. Okay. It is write operation. That means now processor want to write some data onto the output device. For that it is going to send three information. One is data, what data to write, and address of the device, and it is going to send the control signal, is it read or write operation. Okay. And also it is going to activate one more signal called master ready, indicating now it is placed all this information on the bus. Okay. Once this information comes on the bus, whichever the device that matches with this address, okay, it will recognize itself. If so, here the processor is going to check that particular device is ready or not first. Okay. The control bit of S out, if it is set to 0, indicate that printer is not ready to perform the requested task. Okay. In that case, the processor has to wait. In case if processor is, when it is checking the status of the IO device, that is output device, if it is 1 indicate that output device is ready for processing that particular task. Okay. Or displaying or printing the data whatever it is sent by the printer. Okay. So it will be keep on checking until unless S out is 1, it cannot send or it cannot place the data onto the data out. Okay. This is the buffer related to output device. If it is 1, immediately it is going to place the data onto the output device buffer, and also it is going to send the slave ready, indicating that output device is ready to accept the data, and it will be displayed or it is printed through the printer. Okay. And once printing is over, what happens? It has to inform to the processor for receiving the next character. Okay. Or next byte of data. In that case, it has to set the signal called idle. Okay. So if it is idle, indicates that the output device is idle now. So it is ready for accepting the further data. So for that, once again, it has to set S out to 0. S out 0 indicates that. So till as long as the data it is printing, so it cannot accept any further information. Okay. Once the printing is over, so it is going to send the idle signal. Immediately it will set the S out flag to 1. Otherwise it will be 0. 0 indicates the output device is not ready for accepting the further request. Okay. So now, similar to the previous diagram, we have one more circuit diagram for output device. It's very similar to that. Only thing is, here it is going to use the handshake protocol for sending idle signal and valid signal. So other than that, remaining all, it is same. So you can just observe what are the major differences. And this one you don't read, just go through that. It is the circuit diagram for combined input and output. Okay, normally they will not ask the circuit diagram. They will ask for input device, IO interface circuit, and also for output device, IO that interface circuit. Okay, so combined you need to learn. Okay.